So just a short video to talk about the different measures of different kinds of solids that can be present in a water sample. This is a figure from your book. It's figure 2-2. And what did I do with the book? Oh yeah. 2.2. So here it is in your book. This section, which is section 2.5.4, you should read that section. And then I just wanted to talk through this figure real quick. So we take a water sample and we take a certain volume. We're going to pour it through into this Erlenmeyer flask and filter it. And when we do that, all the suspended solids, all the actual particulates that are in the water sample are going to get stuck on the filter. And the filter we use is typically called a 0.45 micron filter, 0.45 micrometers. That's the nominal pore size. So anything smaller than that will go through, and we consider that dissolved stuff is going to go through the filter. And suspended or particulate stuff is going to get stuck on the filter. So then we could take different parts of this. We could take the water itself that's well mixed and put it in a crucible, put it in an evaporative oven, evaporate all the water off, and everything that'd be left would be the total dissolved solids plus the total suspended solids. Particulate and dissolved stuff would be left. That's the total solids. If we take what was on the filter and we weigh the filter beforehand, and then we dry the filter and weigh it again, the weight gain will be all of the suspended solids from the sample. So we call that total suspended solids. And then finally, what went through into the bottom of the flask only contains the stuff that was dissolved, not suspended. And so now we can take that and evaporate that off, and whatever we have from there is going to be the total dissolved solids. Whatever those weights are, we're going to divide by how much we actually had of sample volume to get these measures. So total solids, total suspended solids, total dissolved solids, they're all in like milligrams per liter. The last thing we can do is we can take the suspended solids, we can put it in what we call like a muffle furnace or just a furnace, which is at a much higher temperature, and that is going to actually combust anything that is carbon containing or organic. So when we do that, all that's going to be left of the suspended solids is the mineral stuff, rocks and things, that isn't organic. So whatever we lose from the filter when we put it in the furnace, that's the organic stuff. We call that volatile suspended solids. And that's sort of it's the organic material, but also in like a wastewater sample, as we'll talk about later, it's what we assume is like how much bacteria was in the sample. So that was living stuff that would get ignited. We can do that with the dissolved fraction as well. We can take this stuff and put it in a muffle furnace, and whatever the loss is from the TDS, we would say that's also volatile or organic stuff. So you should read the section, understand what's going on in this figure, and I'll put a couple homework problems so you can get familiar with calculating these things, but you should understand what these different fractions are and how you would get them from an experiment like this.